Hey guys, welcome back. Today we're going to take a look at the study guide for the quiz on 1.1 and 1.2. Alright, so for numbers 1 through 4, we have to identify the function family to which the function f belongs to, and we need to compare, we need to compare the graph of f to the graph of the parent function. In other words, you need to give me the transformations that are occurring. In addition to that, this is all part of that first section up here, you need to identify the domain and the range of the function. Okay, so let's go ahead and begin with number 1. The first thing is the function family. This is the V shape, so we know that that's the absolute value family. And then the second part of this question is to compare the graph of f to the graph of its parent. So we're looking at all of the transformations going on here. In here we have a plus 2 inside the function, so that means that's 2 units to the left. And then we have a 2 out here multiplied by the function, so that is a vertical stretch by a factor of 2. And finally we have the minus 8 way out here outside, and that means down 8 units. Okay, so we did the function family, we did the comparison, and now we're going to do the domain and the range. Okay, so the domain for all these absolute value functions is going to be all real numbers, and the range, we need to find either a minimum or a maximum. We're looking at the vertex, right? The vertex down here is at the point -2, -8. That means the lowest value y can have in this entire function is -8. So my range must be greater than or equal to -8. And that concludes number 1. Oh, and here comes all my messages. Sorry guys, sorry. Sorry. Oops. A lot of fun. Okay. Close all that. And close that. Alright. Now, really? Let's take a look. Let's take a look at number 2. I'm not paying attention. Alright, over here we have what looks like an upside down parabola. In fact, it is. So this function is a quadratic. And the fact that it's upside down tells me that it's being reflected over the x-axis. So we're going to talk about that in just a second. So number 2, the first part is what family is it? The second part of part 2 is what are the transformations that are going on? And here there are 3. You have the minus, you have the 2, and you have the 3. Okay, so the minus in front of the function, that's the reflection over the x-axis. The 2 in front of the function, that's a vertical stretch by 2. And the plus 3 way out here, that means it is going 3 units up. And then the third part is the domain and the range. Again, the domain for any of these quadratic functions is all real numbers. And the range, we have to find either the minimum or the maximum point, which is the vertex up here. This is at 0, 1, 2, 3. So that means that my y value, the maximum value it can have is 3, and the rest of the function is less than or equal to 3. So my range is less than or equal to 3. And that was part 2. Part 3, see if I can sneak it in down here. This guy, obviously a linear function. All right. It has an x value, an x variable to the first power, so it is linear. And this is the first part. The transformations are 2. There is a vertical stretch by 5 and 2 units down. So vertical stretch by 5 and 2 units down. Okay? Domain and range for linear functions, both of them will be all real numbers, all real numbers. Okay? Number 4, I'm going to squeeze it in over here. This one is a constant function, and we're going to let the parent be here at f of x equals 1. All right, so this is the parent. I'm going to call it p of x equals 1. So this one is the constant function. That's the family. And the transformation, if this is the original line, and this is where we wind up, the transformation is up 2 units. And then for domain, up here on this line, x can have infinite number of values. It could be 1, it could be 2, it could be negative, it could be 0. All of the domain numbers, all real numbers. Now the range is limited. Every value of y in that line is going to be 3, and that's your range. Okay, so that's that first part. Hopefully that wasn't too bad. Now for this section, you're going to be given a function. You're going to graph the function and its parent. So you need to have 2 graphs on the same coordinate plane, all right, or 2 functions on the same graph. And then you're going to, again, describe the transformation. So let's take a look at that. I'll just write it again, and then we'll do it over on this side. For number 7, we have g of x equals x plus 4. This is a linear function, so its parent, I'm going to call it p of x for parent, is just x, right? Let's go ahead and graph. This g of x I'm going to do in red, and p of x I'll do in blue. So let's do p of x, which is the parent linear function, and we know that's 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2, and so on. So this is our parent linear function, also known as the identity. P of x equals x. Now if we take a look at the transform function, it has a plus 4 at the end. That means it is shifting this function up 4 units. So we can easily graph this one by taking a couple of points and just moving them up 4. 1, 2, 3, 4, and 1, 2, 3, 4. The minute you have 2 points, you have a line. So let me see if I can get something that's got a straight edge on it. Connect those 2 points and you're done. Alright, and this is g of x equals x plus 4. After graphing the parent function and the new function, you need to describe it, and the transformation is up 4 units. And that's that. Okay, number 8. We have f of x equals x minus 6, and this one will be in red. And the parent is also the linear function, so it's p of x equals x, looks just like that, and we'll do that one in blue. And if we take a look at the transformation, there's a minus 6 outside of the function, so that is down 6 units. Okay, and we're ready to graph. So we're going to graph the original function, the parent function, which is this identity right here, right? 1, 1, 2, 2, 3, 3, negative 1, negative 1, and so on. Again, you only really need 2 points to draw a line. And then we're going to look at the transformation, which is down 6 units. So all I'm going to do is I'm going to bring a couple of points down 6 units. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And we're going to connect those 2 points. And we are done. Okay. Let's taking a look at number 9. So these are all linear. Let's take a look at number 9. Let's see if I can get paper that doesn't have ink marks on it yet. Here we have number 9. We have f of x equals x squared minus 1. This is not a linear function. This is a quadratic function. And this is the transformed function. And this is the parent function. That one's going to be in blue. And if we take a look, the minus 1 is occurring outside the function, so this transformation will be down 1 unit. And we're ready to graph. I'm going to go ahead in blue and do the parent function, which is x squared, so that's 0, 0. 1 squared is 1, 2 squared is 1, 2, 3, 4, and this is a symmetric graph, so we just get the matching points on the other side. Please notice that quadratics are curvy. Do not make this pointy like an absolute value. It is strictly curvy. And then we have the transform function, which is down 1 unit. So I'm going to bring each point down 1, down 1, down 1, down 1. Yes, that was my husband. Down 1. And we're going to connect these. All right, so this is a function shifted 1 unit down. Okay. Number 10. Number 10 is also quadratic. And this is the transform function, will be in red. And the original parent function, p of x, is equal to x squared. So it is going to look very much like that blue one. we're going to look at the transformation. There is a +4 inside the function. That means 4 units to the left, the opposite of what you would be thinking. And let's go ahead and graph. Okay, so let's do the parent function again. 0, 0, 1, 1, 2, 1, 2, 3, 4. And do the other side. Connect the dots, make sure it's curvy. And now we're going to move a few of these points over 4 units to the left. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 8. 1, 2, 3, 4. And then 1, 2, 3, 4. 1, 2, 3, 4. And that's that. Now, if you don't have colors for the quiz, then just please label each of these. This would be P of x. I just remembered that equals x squared. This red one is h of x, x plus 4 squared. In fact, I'm going to go back and label them all just in case. This red one is f of x, x squared minus 1. And the blue one is p of x equals x squared. Go back here. This blue one is p of x equals x, and the red one is f of x equals x minus 6. Okay, and I believe I did it for the first one. Okay, so that's number 10. Let's go on to number 11. So here we have g of x equals absolute value of x minus 5. And this is an absolute value function, so the parent function is just the absolute value. And I'm going to make this one in blue just to keep the same color coordination thing going. And we want to look at the transformation. There's a minus 5 inside the function. That means it is moving 5 units to the right. And we're going to go ahead and graph that. Okay, so I'm going to graph in blue the parent function. Absolute value looks like this: 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2, right? Because you're taking the absolute value, and those have to be positive. So there is your parent. We'll go ahead and call it p of x equals absolute value of x. The transform function is this function shifted 5 units right. So I'm just take a few points and go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And I guess you can guess what that one is because of the symmetry. So this one will be g of x equals absolute value of x minus 5. Okay? Awesome. Number 12. Number 12, we have f of x equals 4 plus the absolute value of x. Now this one might look a little weird to you, so let's make it look less weird by flipping these guys around. This is absolute value of x plus 4. You can absolutely do that. That's just the commutative property of addition. 3 plus 2 is the same as 2 plus 3. So this is going to be f of x, which is the transform function. And the parent function, we'll call it p of x, is going to be the absolute value of x. That one will be in blue. So here and here we have the same parent function. Alright, so off we go. X and Y. Parent function 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. Oops, let's do it in the right color. Sorry. This is f of x equals absolute value of x. And if we look, we have a plus 4 outside of the function. That means up 4 units. So we're going to take a few points and go up 4 units. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then you can see the symmetry and get the other part. And this is, this is p of x. And this is f of x. Okay? And that finishes it for that section. Now we're going to look at the back of the paper and pack. Let me see if I can get a clean one here. Hold on. Just a minute. Alright, here we are. Make this a little larger. Okay, so here we're going to write a function g for all of these, whose graph represents the indicated transformation of the graph. Cross out that use technology. We're not going to do that. So taking a look at number 1, we have f of x equals x minus 5, and we want a translation 4 units left. When we do left, that is inside the function. So that's going to be x plus 4. Okay, f of x plus 4. So I go back up here. This is f of x. And wherever there is an x, I'm going to put an x plus 4. So g of x is equal to, instead of x, x plus 4 minus 5. G of x equals x minus 1. Okay? Taking a look at number 2. Here we have f of x equals x plus 2, and the translation is 2 units to the right. So that's going to be g of x equals f of x minus 2, because it's the opposite of what we think when we're going left and right. So that means we're going to go back up here, and wherever there's an x, you're going to put an x minus 2. So g of x equals x, but instead of x we put x minus 2. And plus 2. Don't forget that, because there's a plus 2 there. And this is going to cancel out, and so you're left with g of x equals just plain old x, which makes sense because this plus 2 means that it was shifted 2 units left. And if then I move it 2 units to the right, I'm going to wind up at the origin, right? Because negative 2 plus 2 is 0. Taking a look at number 3, we have this function, and we want it translated 2 units down. When we talk about down, we are talking about outside the function. So it's the function f of x minus 2. So we're going to plug in for f of x. Let's see, it's absolute value 4x plus 3 plus 2. And then don't forget that minus 2. And these cancel, and you're left with absolute value of 4x plus 3. Okay? Number 4, I'm going to copy the whole thing because I can't see it anymore from here. So we have f of x equals 2 times absolute value of x minus 9. And you want a translation. Sorry about that. Translation 6 units up. Okay, so up and down occur outside the function. So g of x equals f of x plus 6. F of x is this guy, 2 times absolute value of x minus 9. And then we add the 6. 2 times absolute value of x minus 3. That's your g of x. And we have reached the end of our study guide. Hopefully this makes a little more sense to you. Please don't hesitate to contact me in class, ask me questions before you take the quiz. All right, see you next time. Bye.